Hey everyone, welcome back to your math class and back to school after Semana Santa. I hope you all had a lot of fun on your time off, and uh, hopefully you didn't forget the kinds of things that we covered in our math class before the break. But just in case, today we're going to take it a little bit easy. We're going to ease back into the school routine because, as I understand it, you guys had yesterday off as well. So this is your first full day back at school. So I know it's going to take us a little bit of time to get back into the routine and the momentum and all of that. So we're going to take it a little bit light today. But we are going to do a little bit more work with two variables. I was going to focus more on that because I'd meant to record this lesson in time for your last math class before the break, but just for stuff that was going on my end, I had way too many things going on in that couple days, and I wasn't able to do that. So instead, we're going to touch on that today, but today's mostly going to be a review. So the title is a little bit misleading, but for my own sanity and the fact that I named all my files with that title, I'm just going with it. So we are going to touch briefly on working with two variables towards the end, but today is mostly going to be review. So the plan for today is we're going to go over a couple of concepts that we discussed before Semana Santa. In particular, we're going to look at how exponents work, which is a concept that we covered quite a few lessons ago, but because you guys had your time off, I want to make sure that we're all clear on what exponents are and how they work before we dive right back into the algebra. And then we're going to talk about uh, also what we talked about before the break in how to solve problems, algebra problems, where you've got one variable. So yeah, I'm going to show you the step-by-steps of that. I'm not going to go through examples of it in this lesson just because I want to make sure that I have time to go through an example involving two variables. And I don't want to rush through the review bits, so I didn't want to try and cram too much into your first class back because then it wouldn't be, you know, easing back into things. It would have been full of a whole bunch of stuff. Also, I apologize if there's like too much noise or something in the setup. Just let me know. I'm in the same room as the back of the fridge. So if you're hearing like a humming noise in the background, that's what that is. Um, but yeah, so we're going to review those things. Then we're going to review the steps that we discussed briefly before the break, which is how to solve problems involving multiple variables. So in particular, we're going to focus on how to solve problems with two variables. I'm not going to throw too much at you today. We're not going to make it insanely complicated. So we're going to go over those steps, and then following that step-by-step process, we're going to do a proper example involving two variables. Now, before we get into that, I do want to go over a couple of little housekeeping things. So today in this class, so I'm obviously recording this a little bit ahead of time, but in this class that should be on April 2nd, uh, we're going to be reviewing some of the major concepts that we studied before the break. So there were some little intricacies here and there, some little minor details that we talked about before, namely BEDMAS, right? Brackets, exponents, division, multiplication, addition, subtraction, and the distributive property, that thing where you're multiplying something on the outside of brackets multiplied by a bunch of stuff inside the brackets. That's stuff that we talked about in the last lesson or two before the break. So I'm not reviewing those things in this class, but if you want to review those concepts, you can go back to those lessons from just before the break. And if you're still not sure exactly what's going on, or maybe you were struggling with it at that time, let me know and I'll be happy to clarify that. So that's the plan for today, is we're going to go over those concepts, how exponents work and how to solve problems with one variable, and then also how to solve problems with two variables. Next class, that's Thursday, April 4th, we're going to dive a little bit deeper into how to solve problems with two variables. Now that's something that I want you guys to kind of appreciate the logic of what's going on when we're doing math questions that have a lot of steps going on, because there is a beauty to the logic of math. And that's one thing that's really nice about math, is that you figure out how to do this type of question, and if you understand the logic of why you're doing things the way that you're doing them, everything gets so much easier rather than trying to memorize a bunch of stuff without any understanding. So that's why I want us to take our time. We're going to spend next class going into solving algebra problems with two variables, which the way I've written it is a 6-step process. So there's a little bit of stuff going on. Next week, so that'll be next Tuesday, we'll do a little bit more of that. We'll do algebra problems with 2 variables, maybe 3 variables if you guys are feeling comfortable with it. Probably we'll just stick to 2. And then I'm thinking for next Thursday, we'll have a review session of our entire algebra unit and exponents and all of that. And then you guys will have a test the week after that. So I'm going to see how these next couple of lessons go and what kind of questions you guys have. And then I will nail down exactly, this is going to be the day of the test. This is going to be the day that I can do a review session. I think some of you found the review session useful last time, and it's one of the most viewed videos on the channel now. So that was cool. So I'm going to try and do that again because I think it was helpful to some of you to get those questions answered right before the test. And of course, if you struggle with the concepts that we go over in today's lesson, please first go back to the lessons that we did before the break, just because that's where we did the full lesson, right? That's where you're going to get the full, I'm assuming you've never seen this before, kind of a discussion. And if you're still stuck, let me know, and then I'll help you out with the little specific details of where exactly you're getting stuck, right? Because that way I'll be able to help you more if you've gone back and you've looked at those videos and you can figure out, okay, I'm understanding up until this point, then I'm lost. So if you can figure out where exactly it is that you're getting stuck on any of these concepts by going back to the old videos and seeing, okay, up until about 12 minutes into the lesson, it's making sense, then it stops making sense and I need help. Let me know, and then you can tell me that. Go back to lesson 9, minute number 12. I'll go back to lesson 9, minute number 12 and see what you were talking about, or rather see what I was talking about and see where you're getting lost. So yeah, I just wanted to, put that out there because I know that before the break we shifted into a little bit of a more independent system for how your class is going to run, where you're going to be doing a lot more like self-evaluation, that you guys, the students amongst yourselves, are going to be figuring out if things are making sense, if I'm going too fast, too slow, if there's something you need from me that I haven't given you, anything like that. Sound issues, video issues, upload schedule issues, anything like that. You guys are all kind of in charge of your own learning. So I want to make sure that we're all on the same page. And that's why if you can make it easier for me to see where you need help, then I'll be able to help you better. So that's it for all the housekeeping. Now let's get into our review. So we're going to start with a review of how exponents work. So what exponents are and how they work. So just like multiplication, if you think back to when you first learned multiplication, multiplication is just addition happening over and over and over again, right? 4 times 3 is just 3 being added to itself 4 times, or 4 being added to itself 3 times, right? And the thing that makes multiplication useful is it's not just like, oh, this is this like cool way that we can write this down, but then we always have to break it down into an addition problem. No, when you're doing multiplication, instead of repeatedly adding numbers over and over and over again, you figure out ways that you can use pencil and paper to solve a question using multiplication, using different rules, different ways of writing it down that save you time instead of having to just go and add up all the numbers individually, right? So for instance, if you had like 28 times 15, right? That's really just 28 plus 28 plus 28 plus 28, 15 times, right? 15 28s being added together. That's what's going on there, right? Now, if you had your multiplication problem that was 25 times 18, and the only way that you could solve it was to write 25 18 times and then do the addition, you're not really saving yourself any time. In fact, you're adding an extra step of like having to convert from this way of writing the problem down to that way of writing the problem down and then actually solving it. So the thing that makes multiplication useful is that we uncovered these rules, and whether it's paper or pencil or calculators or whatever, we've figured out these ways of solving problems using multiplication itself. So we don't need to worry about doing all the addition by hand anymore. Multiplication acts like a shortcut that gets you to the answer faster by solving the problem differently. So you're not solving the problem the same way, because if you were solving the problem the same way as addition, you would just be adding all the numbers together. So multiplication, like with long multiplication, you're not really following the same process as you did with addition. The way you write it down looks kind of similar, sure, but you're doing different stuff with that once you've written it down. So similarly, exponents are to multiplication what multiplication is to addition. So exponents, or like the process of like doing an exponents problem, that's called exponentiation. So exponentiation is just multiplication happening over and over again, just like multiplication is addition happening over and over again. So with exponentiation, and you've got, I put an example down here for you, you've basically got one number being multiplied by itself again and again and again. Just like with multiplication and addition, you're just adding a number to itself again and again and again. Same thing is happening here, just we're doing it with multiplication instead. Now, the way that we write it down when we're dealing with exponents is you've got like a normal sized number, which is this 4 here, and then a teeny tiny number that the technical name for that kind of number is a superscript. That's this little guy up here. So the normal sized number is called the base. The little guy up there is called the exponent, and together the whole thing, 4 to the exponent 6, is called a power. And so what information do you get when you write it down this way? Well, the base, so the normal size number, this 4, is the number that's going to get multiplied by itself again and again, right? So you've got a bunch of 4s being multiplied together because the 4 is the base. The exponent tells you how many times to multiply the base by itself. So here our base is 4, so that tells us that we're going to be taking a bunch of 4s and multiplying them together. How many 4s? That's the information that we get from the exponent up here. So this 6 is telling you that you're going to take the base and you're going to multiply it by itself 6 times. So we've got 6 instances of the number 4. We've got 4 times 4 times 4 times 4 times 4 times 4. So that's, we've written down the number 4 6 times, and we've stuck multiplication signs between them. So that's what you get information-wise. That's the information that you get when you write down a power like this. But so far, I mean, I say so far, we've already talked about this before the break, but just this information doesn't tell you why exponents are useful, right? Because if you see this 4 to the exponent 6, if you see this power right here and you think, well, I know that means 4 times 4 times 4 6 times, that's great, but I still have to do all of that multiplication by hand. I still got to do 4 times 4 is 16, 16 times 4, and then I got to pull out my notebook and I got to write down 16 times 4, 64, and then I got to 64 times 4. That's not saving me any time, right? Writing it down like this is all well and good, but if I'm not able to do anything with that and I'm going to just have to write it down like this, why am I using exponents? So the key there is exponent rules, which we also talked about before the break. So I'm going to put that on the next slide. So yeah, before the break, we'd also talked, I think, a couple of times about exponent rules. So this is, I've just copied the text from that slide directly onto this one because these are the rules. So the first rule is called the product rule. So if you've got two powers where you're multiplying the two powers together and the bases are identical, that's what happens. That's what we're trying to indicate if we write down the same letter here as we do here. If these two letters are the same, this A in the base here and this A in the base here, that means that the product rule only works if the two bases are the same, because if they're not the same, then you're not following what this is trying to tell you. So if the two bases are the same and you're multiplying the two powers together, but they've got different exponents, or they could be different exponents, then the product rule says that you can rewrite that as a single power where the base stays the same as it was before, but you add the exponents together. Similarly, the quotient rule, that's just the same kind of idea, but in the opposite direction. So instead of multiplication, we've got division, and instead of addition of the exponents, we've got subtraction. So if you've got two powers, one power divided by another, and they've got the same bases, then you can subtract the exponents. So you take the first exponent minus the second exponent. So those are those two rules. Those are going to come up all the time. The next one is the power rule, which is that if you've got a power and that entire power is raised to an exponent, like we've got this whole power sitting in the brackets here, you can rewrite that as a single power where you multiply the two exponents together. So if this was like, for instance, if you had like 2 to the exponent 3, that's your power, and then you put that in brackets and you raise that entire thing to the exponent 4, this rule is telling you that that's the same thing as 2 to the exponent of these two guys multiplied together. 3 times 4, which is 12. So that's telling you that that's the expression that you get. You get that this thing is the same as that because you can multiply the two exponents together. That's just what the power rule is telling you. And we've got a few other rules here. We've got the fractions rule. That's not the proper name for it, but it doesn't matter. Where if you've got a whole fraction being raised to an exponent, you can stick that exponent into a little mini power here and a little mini power down there. So the numerator can become its own little power where you take the numerator and the exponent and you put them together as one little power up top. And then the denominator becomes its own little power where you took the original denominator and the exponent and you made a little power down there. That one we're not going to see too much just because, you know, it's not going to come up as often as like these three up here. And then a couple that are just like useful tools to have in your toolbox. The first one is the zero rule. Again, not the actual name for it, but any base, doesn't matter what it is, to the exponent 0 is equal to 1. And the last one is the negative exponent rule. So if you've got in the exponent, if you've got a negative sign, then you can rewrite the whole thing by taking that whole power, and if it was like the numerator of a fraction, you chuck it into the denominator of a fraction. So remember that this thing is really the same thing as that, right? If you divide something by 1, you haven't changed it. So this is a fraction kind of in hiding, right? You've got this power up top as the numerator divided by 1. You don't really have to write divided by 1. It's like this invisible thing, but it's technically a fraction with a denominator of 1. And so the negative exponent rule tells you that you can flip that fraction over and wipe out the minus sign from the exponent. So if you don't want to deal with the minus sign, then you can write it out like that instead. And then at the bottom, I've added an example of what makes exponents useful. And the thing is, these exponent rules, these are what make exponents useful. And so the example that I've given is this problem right here. I probably should have made some of this a different color, but this thing right here is like your example question. And exponent rules are what make this really easy to solve, because without exponent rules, you have to write this guy out as 2 times 2 times 2 times 2 times 2 10 times, right? That's what this guy is telling you, that you're going to multiply the number 2 by itself. How many times? 10 times. That's the information that you get out of the exponent there. And then over here, you're going to have to do 2 times 2 times 2 times 2 times 2 8 times, right? So again, multiplying 2 by itself, how many times? That's what the exponent tells you, so 8 times. Now, if you were trying to solve this without using exponent rules, you're going to have to do this whole multiplication. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, and so on, all the way up until you get to 2 to the power 10, which is a big number. And then you have to divide that by another big number, right? 2 times 2 times 2 times 2, 8 times is also going to be a big number. And then you have to do that division, and it's going to be like the hardest long division question that you've ever done. And you're going to go through all that work just to get an answer that ends up being 4. Whereas what you could have done is if you used the quotient rule, well, we've got the same base, right? We've got a 2 here, we've got a 2 there. We've got different exponents. We got a 10 here, we got an 8 there, and we've got a division sign in between, right? The division sign is in between. So what that tells us, what the quotient rule tells us, is you can rewrite that as 1 power where the base stays the same. So we've got this 2, and then you subtract one exponent from the other. So here it was b and c. Here it's 10 and 8. So we have 10 minus 8 up top. 10 minus 8 is 2. So that means that we can write our whole power, this whole complicated division problem with 2 powers, is the same thing as 2 to the power 2, or 2 squared, which is 2 multiplied by itself 2 times. So 2 times 2 is 4. And you never have to figure out what 2 to the power 10 or 2 to the exponent 10 is, or 2 to the exponent 8. You don't have to go through any multiplication at all until you hit this 2 times 2 right here. And then you've got to do, sure, you've got to do a little bit of work. Sometimes the exponents won't save you that much. If it was a different problem and you got an answer of 5 cubed, 5 to the exponent 3, sure, you do have to do 5 times 5 times 5 to get your answer. But maybe you started off with something huge over here. Maybe you started off with 5 to the 23. Like, good luck solving that. I'm not doing that. My calculator's not going to bother. You have fun, you know? But if you can take advantage of exponent rules, it's not always going to be the quotient rule. Sometimes it'll be the product rule. Sometimes it'll be the power rule. Sometimes it'll be the zero rule. One of my favorite questions to kind of try and scare you guys on a quiz or a test, and the same thing that my math teacher did to me, is he'd give you this big long expression and there's like a whole bunch of stuff going on, math symbols you've never seen before, and it's all put in brackets with a little exponent 0 at the end of it, and it says, what is this equal to? And if you didn't study, if you didn't read the question right, you didn't see the exponent 0, you start sweating, you start panicking, that, oh my god, how am I going to solve this question? I don't even know what half of this stuff means, and you spend half the test sitting there not knowing what to do and feeling like you missed a chapter or a class or like 5 classes. Or you notice the exponent 0 and you say, oh, this is equal to 1. I don't even have to solve anything inside the brackets. I just know this is equal to 1. Move right on. It would be a 1-mark question, and that was his hint to you to not freak out, was it's a 1-mark question. So I would do the same thing to you guys. That's a heads up. You're probably going to have a question on the test that's like, wow, this is going to be like 5 minutes of work, 7 minutes of work if I chug through all the itty bitty steps. Or I notice there's an exponent 0 here, and the answer is 1, or like 1 plus 1 or whatever, right? So yeah, so exponent rules, very, very useful. And that's something that I want to make sure that you guys are totally comfortable with. Now, solving problems with one variable. This is something that we've talked about plenty of times before. So here are some key takeaways. I'd put this screenshot in a previous lesson, and this screenshot was from a lesson that was even before that. So this is I'm reusing it yet again, but these are the key takeaways for solving algebra problems with one variable. So basically, if you have one unknown value, one variable, one letter that's showing up one time or multiple times, as long as it's just the one letter again and again, what you have to do is you have to isolate that variable. So the way you do that is you try and get all the different terms, all the different little pieces of your equation that have your variable. So let's say x, because we've always been using x. You get all of those things with x on one side of the equal sign, and all the things that don't have x, so all just the regular numbers, on the other side of the equal sign. If you have multiple things with x's going on, you might have to do a little bit of simplifying there until you've got just one little object that's like a number times x or something. But your ultimate goal when you're isolating a variable is to have just an x by itself on one side of the equal sign. So there's no numbers attached to it, it's not multiplied to anything, it's not added, subtracted, divided, none of that. It's just x by itself equals something, some collection of numbers and a bunch of other stuff going on between the numbers, but no x's on the other side. So that's what isolating a variable is. And the way we do that is we follow the BEDMAS steps in reverse. So if you've got this big long expression and you've got x's scattered throughout the middle of it, you want to get rid of the things that don't have x's through addition and subtraction first. Once you've gotten rid of those things from one side of the equation, then you get rid of anything that you can by multiplication and division, then by exponents, and then dealing with the brackets last. So we follow BEDMAS in reverse. If that's confusing, because I'm kind of breezing through this a little bit quickly, go back to, I believe this screenshot was from lesson 9. If it's not lesson 9, it's lesson 10. So I think it's lesson 9. So go back to lesson 9 and rewatch that if you need to see some examples. That'll be in lesson 9, lesson 10. Yeah, and if you still need help, then by all means, let me know. Yeah, and it is a little bit tricky to get right, but now we've done quite a few algebra problems since then. So hopefully with just an example or two, or like going back and rewatching some of the examples, it'll come back to you pretty quickly. So now we get into the main topic that I wanted to talk about for today, and we're going to take it a little bit easy. We're just going to review these steps. We're going to try and figure out what's going on with all these colors, and then we'll go through one example. So just an example. I'm going to walk you through the problem, and then after that, next lesson, we're going to do some more. We're going to do a couple of examples. We're going to do some practice questions, maybe some word problems. And once we start to feel comfortable with working with two variables early next week, we'll do a test review and a test, and then we'll start using these tools that we've developed to go into more interesting areas of math. So first things first, in order to solve a problem with two variables, you need to be provided with two equations. So if it's not a word problem, I'm going to provide you with the two equations. I'm going to say, figure out what x and y are equal to in the following. And I'm going to have one equation that's got x's and y's scattered throughout it, and I'm going to have a second equation with x's and y's scattered throughout it. So you don't have to worry about that. If it's a word problem, and I'm asking you to give me like the answers to two different things, it's like find the, I don't know, size of the baseball field and how much it's going to cost or something. I don't know. I haven't thought of a question. If I'm asking you for the answers to two separate things, there's a chance that it's a two variable problem. And if it's a word problem, you might have to come up with the equations yourselves. And that would be something that you'd have to make sure that if I'm asking you for the answers to two things, you need to have two equations. If I'm asking you for the answers to four things, you need to have four equations. I'm not going to do that to you. We might just, as like a fun like mathematical excursion, we might look at how to solve a problem with four variables, but I would never give that to you on a test unless we'd spent like two whole classes working with it. So here are the steps to solving a problem with two variables. Assume that you have two equations in front of you and you're just being asked to figure out what x and y are equal to. So first things first, just for organization's sake, label your equations. So for example, equation 1 and equation 2. You can write out the full words, equation 1, equation 2. You can write out EQ1, like EQ1, and EQ2. You can do a 1 with like a circle around it or like a box around it. Whatever tells you that this is one equation, this is the other equation, that's how I'm going to talk about them. You could call them A and B. You could call them the red equation and the blue equation if they're, whatever works for you, right? As long as you can tell them apart from one another and talk about them with regular words, right? So that's your first step, labeling the equations. Now, isolate one of the variables in one of the equations. So typically in the questions that I give you, one of the equations is going to be a lot simpler than the other. And you're going to see this in the example that we go through in a couple of minutes. One of the equations tends to be a lot simpler than the other. It might still have x and y in it, but it'll be really easy to isolate one of the variables. To get just the x or just the y by itself on one side of the equal sign will be really, really easy. Sometimes it'll already be done for you. Sometimes I'll be nice and I'll give you a question where one of the equations is already isolating for one of the variables. So that'll tell you, the whole point of doing that, isolating one of the variables, is suppose you get like x equals y plus 3. You do your isolating thing in step 2, and you get x equals y plus 3. Once you're all done your work, you figure out this is what you get when you isolate for x in one of the two equations. What that tells you is now you can go into the other equation, and anytime you see an x, you can write down y plus 3 or whatever it is, in your particular question, whatever you solve for x, you got something else that x is equal to something that doesn't have any x's in it. So if you isolate x through one of the two equations, that tells you how you can write x using other stuff, using numbers, using the other variable, using anything that isn't this variable itself, right? So if you isolate x, that tells you how to write x in terms of y, in terms of numbers, in terms of anything that isn't an x. And so that's what's going on with all the colors here. Is suppose you're isolating for one of the variables, we'll call it x, here it's like the red one, in one of the equations, that tells you how to write that same variable using numbers and the other variable. So here I'm trying not to use x and y because I don't want you to think that you have to isolate x or that you have to isolate y or a or b or whatever, right? You pick whichever variable it is that you want to isolate, whichever one that you think is going to be easier to isolate, and do that. Sometimes it'll be x, sometimes it'll be y, sometimes it'll be equally easy or difficult for either one, and you just pick one, right? So doing this isolation, you get an expression that's something like that, this x equals y plus 3 business. Using that expression, you're going to rewrite the other equations. So you see here I'd colored the equations green and purple. So in the green equation, you do your isolating, and then you take that result and you go over to the purple equation. You go to the equation that you didn't touch for isolating, and you're going to rewrite that expression, that equation, using only the second variable, because the whole point of isolating the first variable is so that you don't need to use it anymore. So you go into the other expression and you rewrite it using only the second variable. That turns it into a problem of one variable. So now you can go ahead and just solve for that variable. You do the isolating if you have to, you do your calculations, you get an answer. With that answer that you get for the second variable, you go back to the first equation. So you see we started by isolating in this green equation. Then we went over to the purple equation, did some math, got an answer. Now we come back to the green equation, come back to the first equation, and then using the answer that we found for the other variable, we're going to use that to figure out the answer to the first variable. So there's a little bit of a back and forth. You isolate x in equation 1, then you take that answer, you go over to equation 2, you do some math, you get an answer for y. You get an answer for the other variable. Then using that answer for the other variable, you come back over to this equation and you figure out what x is. So there's a little bit of a back and forth there. But all in all, it ends up being about a 6-step problem. If you think you should break this up into more steps so that it makes sense for you, that's okay. Totally feel free to do that. But it's hard to kind of use a whole bunch of words and colors to explain this. The best thing is an example, and then the actual best thing is practice. So today we're going to round out this class with one example in the next few minutes, and then next lesson we'll do some practice. So here is the example. Solve for x and y given the following. See, I told you I'd give you the two equations. So here's the first equation. 3x plus 15y equals 45. And then we've got x minus y equals 9. So you can already see this one's got like a whole bunch of stuff going on. There's a whole bunch of numbers. There's like multiplications going on, right? 15 times y and 3 times x and all this weird stuff, right? And the second equation looks a lot simpler. So I'm already eyeing this up as like, okay, that's the one where I'm going to isolate. I don't really care whether I isolate x or y because it's going to be roughly equally easy to isolate either of them, right? But I'm already eyeing that up as the one that I'm going to use to do my isolating in that first step. So the actual first step, label the equations. I'm going to say this guy right here is equation 1, and this guy right here is equation 2. Now, I personally, if I was writing this with paper and pencil, I never write it like this. I don't write a statement, I don't write a sentence. I just put a 1 in a circle up here. That's a horrible circle. And I put a 2 in a circle here. And that's it. And I write them a little ways away from the numbers because I don't want to put like a 2 right here and then think that like, oh, that's 92, right? I don't want to think that that's what's going on. So I write it a little distance away. I write it in a circle or in a box and like above or below the equation, just so I'm not confusing myself, right? So here we go. I've labeled my equations. This is equation 1. This is equation 2. Now, the way I wrote out the steps is isolate one of the variables in one of the equations. So what I'm going to do is I'm going to isolate x in equation 2. That's just my choice. You could isolate y. You could do it in the other equation if you wanted. Doesn't matter. I'm going to isolate x in equation 2, and I get that x equals 9 plus y. So you can get that by adding y to the left side and to the right side in equation 2. You'll get x minus y plus y, that's just x, equals 9 plus y. So you get x equals 9 plus y. Cool. Now, so we just did our work with equation 2, right? Solving for x, or isolating x in equation 2. Now we're going to take that answer that we've figured out that x is the same thing as 9 plus y. I'm going to take that information, I'm going to go over to equation 1, and anywhere that I see an x, I'm going to write down 9 plus y. That's the whole point of this step right here. So we had x equals 9 plus y. I'm going to take that information. X is the same thing as 9 plus y. I'm going to go over to the other equation, and I'm going to rewrite it using this information. So that's the whole point of step 3. Using this new expression, rewrite the other equation. So we've gone into equation 1, which was 3x plus 15y equals 45. So I've replaced the x with 9 plus y. So we've got 3 multiplied by 9 plus y plus 15y equals 45, right? That plus 15y equals 45. I've just taken that right from equation 1, just from what it was. And at that point, solve for y. This is a one variable algebra problem. We know how to do that, right? So you can just solve for y at this point. You got to do a little bit of that distributive property stuff that we talked about briefly before the break. So you multiply the 3 by 9, that's 27. You multiply 3 by y, that's 3y. And then you just keep the plus sign in between them. So you get 27 plus 3y, that's just this piece right here, becomes this piece right here, plus 15y equals 45. Hopefully nothing too wild there. Then I'm going to do a little bit of massaging of this equation. So 15y plus 3y, that's 18y. And I'm going to subtract 27 from both sides. So the 27 disappears from the left. 45 minus 27 on the right is going to be 18. So I get 18y equals 18. That means y must be equal to 1. So now I've figured out what y is equal to. Now we got to take this answer for y. We did all this work using equation 1, right? This guy with the 15s and the 45s and all that. That's what we were using to solve for y. So now we take that answer from this equation and we go back to the other equation. And here we rewrite the second equation using the fact that y is equal to 1, which we just figured out in step 4. So we get that instead of x minus y equals 9, I can write x minus 1 equals 9, which obviously tells you that x is equal to 10. And just to be sure that you've done everything right, check that your answers make sense. So what that means is plug in the numbers that you got for x and for y into each equation and see if you can get that the left side is equal to the right side for both equations. So if you plug in x equals 10 right here and right here, that's awful. And then you plug in y equals 1 here and here. Then over here, you'll get 3 times 10 is 30. Oh my goodness, forgive my writing. And 15 times 1 is 15. And then you're adding those together. So you get 30 plus 15 is indeed equal to 45 on the left-hand side, which is the same thing as what we got on the right-hand side, equals 45. Fantastic. So it makes sense on that side. And then this one over here, that's literally just 10 minus 1 is equal to 9. So you get 9 equals 9 on the right-hand side in the second equation. So that's how that works. And that is all that we're going to talk about in today's lesson. So I know that with this being the first day back at school, you might have had a little bit of a late start or something. So if you didn't quite get through this video all in class and you're finishing this a little bit after that or in the next lesson or whatever, that's okay. That's the whole point. That's kind of what I expected because that's how Semana Santa worked when I was there. So That is everything for today. If you have any questions at all, please let me know. Go back and review the videos from before the break if you just like forgot that we talked about two variables or exponents or bedmass or whatever. But let me know if you need any help, and try and be specific in telling me where exactly it is that you're starting to get confused. And that can be difficult to figure out, and if you can't figure it out, that's okay. But if you tell me something like, I understood lesson 10, but not lesson 11, I can work with that, right? I can go back and see, what did I talk about in lesson 10? What did I talk about in lesson 11? Where's the disconnect, right? So something like that. But yeah, let me know. I am always available, although maybe a little bit delayed in responding sometimes. But I'm here to help you guys out and show you the beauty of math. So please don't be terrified. I know math is a little bit of a hard subject. Algebra is hard. It's got a bad rap for being confusing, but I'm going to try and make it not confusing for you guys. So thank you for your time and attention. I look forward to your questions and to exploring the wonders of math with you in the next few classes and in the next few weeks and months. So if I don't hear from you before our next class, have a good one.